Get started, please. Stop. So, my apologies for not being here yesterday. I kind of mentioned to you guys, some of you at least, I think I told you, that I went to Las Vegas for, my brother-in-law was running a race. It was a 24-hour obstacle course race. So obstacle courses, like you've heard of Tough Mudder maybe, or Spartan races. He is actually a Spartan racer. Will you open the door, please? He runs Spartan races on the reg. And this race was called the World's Toughest Mudder. So it was a 5-mile course, and you ran as many laps through the course as you could in 24 hours. So I was there after every lap to help him, refuel, fill up his water bottles, change his shoes, put him in a different wetsuit, like all kinds of stuff. And he actually ended up winning the race. So he did. I'll give you the math on this one. Yeah, you guys are so kind. I'll send him the video. He ran 19 laps.
Whoa.
Which is how many miles?
Way on the calculator.
5 miles per lap. 95 miles this dude ran. In 24 hours. So it's impressive. He ran the entire 24 hours. Like, he just kept running. Our little the pit stop, or the pit crew, the longest stop was he stopped for 7 minutes. That was only because it took us that long to put on his other wetsuit, because he had whatever. Because a wetsuit on wet, if you've ever tried to put a wetsuit on when you're wet, it's not a fun experience. So we were having a really hard time. And after this was the longest pit stop was in the morning. Hey, come on. The race went from 2 p.m. to 2 p.m. the next day, 24 hours. And in the morning, so it was like 7 in the morning, he'd already been running since 2 the previous day, so that's already 15 hours. He'd already been running for 15 hours. It was to the point where he couldn't, we had to hold him and put his wetsuit on. His body could only run. There was no, he couldn't put his shoes on, could barely, he wasn't able to eat very much. It was crazy. Anyway, that's the story. It was incredible.
That doesn't
It was really
sound
cool.
healthy.
Yeah, well, no, on a track, the record for the distance run in 24 hours on a track is, I think you said 160 miles someone's ran. But this was an obstacle course race, so there were 20 obstacles each lap. So he did 5 miles plus 20 obstacles 19 times, which is just... The obstacles were, there was, I don't really know what they were called. They have weird names. One of them was a 30-foot cliff jump into water, and then you had to swim across the water. There was, things where you jump and swing and try and, one of them was you had to jump, you were on a platform, jump to a trampoline, up to a bar, and then the bar swung you across, and then you had to land, across a moat, and if you fell into the water, it was bad. Yeah, and so...
Were there sharks?
No sharks, yeah.
Is it like a burger ninja?
That's a running ninja warrior. I don't know. More running between each obstacle. There was a warp wall, but yeah. I did not. No, I did not. Because I was tired, I wasn't as tired as he was, but I stayed up all night. And so I stayed up. I got there Friday night late, slept, and then it was all day Saturday, Sunday, and then my flight got delayed. That's why I didn't come yesterday, because my flight got delayed, and I didn't get home until 2 a.m. on Monday morning, Sunday night, however you want to think about it. And I hadn't slept, and I was tired, and it's for your benefit that I did not come to work. You wouldn't have said that if I was here. You'd be like, why are you here? Anyway, so that's the story. It was awesome. You could look it up if you want. His name's Chad Trammell. He's a badass. Chad Trammell. Just look up World's Toughest Mudder, or look up weird obstacle race Las Vegas, and I'm sure whatever you want, you'll find it. Okay, that's my story. Anyone else okay? That's good.
I'm doing
For What? Major what? No, I can't. Started. Can't. Oh, also housekeeping. Yeah, I know. I didn't grade. Sorry. You'll notice if you didn't write down your planner, that's on you. It was written. Some of you wrote it down on Friday because you're like, oh, Ms.Stolte, I see you writing that down. Some of you wrote it down on Friday. Amazing. Okay. I'm looking for 50 through 54 is due today.
Yep.
Okay, that was Friday's homework. Tonight's homework is 55 through 61. And you'll notice, if you looked up at the calendar, is that we are having back-to-back math days. What? So, as we told you last week, Mr. Hershey and I will both be gone on Thursday and Friday. Wow. And as a reminder, if your name shows up on that sub-report, you will be getting A, referral, and B, boot camp. Okay? Also, I'll point out that one of the subs will have direct access to me and Mr. Rishu the entire time she's here. Okay, so, and she has done this before, where she has texted me a student's name during class. Oh my gosh. Anyway, all to say, I'm just telling you that you know the expectation. So those of you who think we're trying to break this habit, like, no, whatever you're doing is no. Yeah, cool. Time and place. Just to say, you know how to be on task. You guys are going to have a project that you're working on. We'll talk to you more about the project tomorrow, just so you can't be like, I've never heard of this. Oh, crazy. Okay, because that's not going to fly. You'll be working on a project that I think is going to be kind of cool. If you finish early, you'll have elevations to make sure you're done with. Remember that those presentations are next Tuesday. So think about that. The expectation is that you know what we expect from you, and that you are helping the people around you. Because sometimes there's some of you who just might be tempted to be an idiot. And yeah, I'm asking the rest of you who have good brains to remind your peers, like, hey, come on, man. You can be terrible when Ms.Stolte comes back. Okay? Okay. So, that being said, here is your warm-up today. What? What? Well, that is not an invitation to start talking. Incorrect. Shh. All you should have done is got out your notebook. Chris, that doesn't need you to talk to anyone about it. So, almost had it. Supposing we have a regular pentagon. Why does someone be done? It's almost a regular pentagon.
Close enough.
Just write that notch to scale and it will be. It's an A. Hey. I'm going to give you a hint. if I were to consider breaking this pentagon up, that's an A, not a number. If I were to consider breaking it up into triangles, what type of triangle would that be? That's not a right triangle right there. Equilateral. This triangle would be an equilateral triangle. Okay? So, this triangle would be an equilateral triangle. So if you know this distance, you know this distance. Because equilateral means all sides the same. That's all I'm going to tell you about that. It's an A. Okay. How about 50 through 54, please? As a note, I'm just going to tell you because a few people tried to argue with me last class, so just in case you're feeling as spicy. If you tell me that the problem doesn't tell you to show your work and you think that I should still give you credit for it, I just might slap you upside the head. Okay? Because I have told you every day that you need to show your work. Raul, why are you interrupting? Okay? Yes, you have to show your work. If your work is not shown, no, I'm not going to give you credit. And if you say to me, but I did it, cool, then show your work next time. Because I'm not giving you credit if you didn't show your work. I'm not giving you credit if you didn't show your work. 50 through 54, have them out. Work on this. I would suggest you work as a team.
Okay, wait.
What?
So I understand you do 6.
We did this problem, this sub-problem, this one. We did that problem like 4 times on Friday. Same problem. So, some of you are like, chill out. You've done it a bunch of times. Now, I'm not saying you need to be a master right now, but I'm saying you should be able to go like this. Oh, I'm doing my warm-up today. That's fantastic. Warming up. Like, what were you doing last class? Because I don't remember. Oh, check it out. Look, there's an equilateral triangle where I was trying to find the height. The only thing I did now, instead of making the height of that equilateral triangle, okay? So, when, again, I'm looking at this triangle, essentially, I'm going to redraw that triangle just so I can draw it out there. It's equilateral. Boom, boom, boom. All 3 sides are the same. I know that this is 12 inches. How do I know that's 12 inches? Because that's 12 inches, and this is a regular pentagon, and all this sides are the same. So, if that's 12 inches, how long is this? 12 inches. So really, the triangle I'm concerned with, though, is this right triangle. So if I'm concerned with that right triangle, and this is 12 inches, what's this side here? 6, because 6 is half of 12. And if I'm trying to find the height, or the apothem, or the missing side, Malachi, you're looking at the wrong person. Okay? If I want to know that apothem, I can use my Pythagorean theorem that says that squared plus 6 squared equals 12 squared. And I can say a squared plus 36 is 144, and blah, blah, blah. We're doing that kind of a little bit backwards Pythagorean theorem. So I get that a squared, 108. So that I can square root and have that a is root of 108. Yay! But because I've been paying attention for the past few weeks, I also know that I can simplify my square roots. You might choose to do a factor tree. I don't feel like doing a factor tree right now. Unless, does anyone like really want to see a factor tree? Hey, fine. Fine. Fine, fine. Factor tree. Factor tree. 2 times 54. 54 is 2 times 27. 27 is 3 times 9. 9 is 3 times 3. Boom. Factorific. So that my factors I've got a 2, a 2, a 3, a 3, and a 3. 2, a 2, a 3, and a 3. So, you go out in pairs. There's a twosies. Not a twosie, that's something different. But that comes out in front. Pair of 3s. Those come out in front. And then there's this little lonesome Levi 3 stuck under the square root. Okay? So that I get for my answer, my simplified answer would be A is equal to 6 root 3. Now, unfortunately, that was not the question. The question was, what's the area of that pentagon?
Nobody cares, Levi.
I care. So, what? How about 5? Okay, Matthew. You almost had it. T for timeout. The question was, what's the area of this pentagon? Now, we did all this work just to find out what the apothem was. We found out the apothem, but now my question is, what's the actual area? For the pentagon, I know that the area is the apothem times the perimeter divided by 2. The area is the apothem, perimeter divided by 2. The apothem we just found out is 6 root 3. Perimeter, 12 inches on each side. There are 5 sides. 12 times 5 is 60. 60. Divided by 2. So if I want to multiply those all out, if I want to multiply those all out, 6 times the square root of 3 times 60 divided by 2. My answer of 311.8 square inches. Quick note. Some of you are so sad when you get your quizzes back. Because you didn't put units on your answer. And you got the right answer, but you didn't put any units. It's gonna be rough. So, nope. So, just as a reminder, the 2 things that I have told you since, I think, nearly day 1, that day back in August when we started school. You have to show all your work, and you must include your units. Well, I said it certainly the first week, right? I've said that for sure, at least. Actually, the very first thing I told you on day 1 was don't interrupt me. So. And here he is still. Boy. Okay. Real quick, you only had 5 problems for homework. You have then 5 minutes. I want you talking specifically about the problems in your homework. I do not want to hear other conversation. Talk about each problem. That gives you roughly 1 minute per problem. Talk about your answers. Talk about your methods. Decide who is right. Go. Homework. Here are the answers.
B is wrong.
No. We're okay. I got thick skin.
It's asking for something. Okay.
Thank you. Questions? Questions? Yes. 52. Anything else? 51. Okay, 51. 53. Okay, 51 and 51 and 52. You still need that? You just need to divide, so I'm not going to talk about that one. Okay. So, for 51, the problem with 51 is that... Oh, baby. He called you Dave. Okay. Are we good on answers? 51, we said. 51. No. What up? Okay. Hey, shut up. You guys are lame. You know what? You didn't even roll it up like a ball. I actually wasn't trying. Oh, do you make the rules or I? You want to throw things in class? Go be a teacher. It's the most rewarding career you can have. Okay. Shut up. God, I'm sorry for throwing the paper. Just be quiet. Okay. Matthew. Yeah, try it, Major. That'll be fun. Okay, 51 tells you. We got a lot of serious stuff to cover today. Just warning you. I'm trying to make it light for you. No, 51 tells you this. It says there's some stairs. This is what I did. There's some stairs going up to 9 feet, something like that. And it tells you that the tread on each stairs is 10 inches. So I was like, oh yeah, okay, a stair. This is 10 inches, and I don't know the rise of the stair. I do not know the rise of the stair. I do know it has a slope of 3/4. So if it has a slope of 3/4, what's the rise? Slope is rise over run. Rise over run. Rise over run. The rise would be 3, the run would be 4. So that if I'm trying to figure out what the rise of my stair would be, pretty darn good. If I'm needing to find out the rise of my stair so that it fits this slope, I would figure out, okay, cool, what's my multiplier here? My multiplier there is 2.5. And I would use the same thing here. Say, okay, there. My multiplier is 2.5. 3 times 2.5 gives me my answer of 7.5 inches for the step. Okay? So that if I'm trying to figure out, okay, great, the rise of each step is 7.5 inches, and I want to know how many steps I need to get up to 9 feet. Problem numero uno is that I need this 9 feet, inches. To get from feet to inches, I know there's 12 inches in a foot, so I multiply this guy by 12 and get 108 inches. So my total steps is going to be this 108 inches divided by that 7.5 inches. So total steps, 108 inches divided by 7.5 inches. Okay, now listen, we're talking about number of steps. You can't have 14.4 steps. So here's the question to think about. If we round down to 14 steps that are going to cover 9 feet, are my stairs going to be more or less steep? More steep, right? Because if I round down to 14 steps, that means each step is going to be a little bit taller. So my slope is going to be a little bit steeper. If, on the other hand, we round this up to 15 steps, if you have more steps, right, each step gets to be a little bit shorter. So overall, the steps are less steep. So here, the total steps, yes, this equals 14.4. So we would need 15 steps to meet the code. You would need 15 steps. So there's some rounding you had to think about there. Will you open the door, Stephen? Okay. We're done. I said already you're done. Stop before you irritate me endlessly. So lots of you guys. It's a ruler. Lots of you guys really tried to fake it on 52, which not a very good call. Okay. You have the points. Negative 8, 1, that's J. So, these are my two sets of points. And if I'm trying to tell whether or not those lines are parallel or perpendicular, I need a nice long line. It's JK, right? So, perpendicular means they meet at a 90-degree angle. Yeah, you gotta be able to see where they cross to tell if they're perpendicular, because perpendicular means they meet at a 90-degree or right angle. And if I'm looking at these, my ruler's a 90-degree angle, and I would say, heck, those are pretty darn close for graphing. Those are perpendicular lines. Yes?
Is it right here without graph?
Yes. Quick answer. You find the two slopes. Slopes of perpendicular lines are negative reciprocals.
Google
It means the slope here, the slope from LM is 1/3, and the slope of JK is negative 3 over 1. It's for you. That's for you. That's why I didn't tell you. Okay. Now, in your notebook, we have stuff to talk about. Some of you guys, after last class, were not very excited about our special right triangles. So we are going to talk about more special right triangles just to increase your excitement. I'm going. Hold on. Jeepers creepers.
Oh, yes.
Okay. Remember on Friday, I'll remind you that we were trying to see who could find the length of the hypotenuse quickest. And I gave you candy if you're quicker, and Michaela was judging. And some of you really, really pushed the line of integrity, whether you already wrote the square root of 2 and you just filled it in when I rolled the die. Cecilia. And we talked about this pattern. We noticed every time that there was a pattern, okay? So here's what we were talking about. Recall, for a 45, 45, 90, right triangle, it would look something like this. Okay, if I had a 45, 45, 90 triangle, and we wrote this in our notes last time, we said that whatever the legs were, how would I get the hypotenuse? How would I get the hypotenuse?
Wouldn't it be the square root of the 25 legs?
Maximus.
I know, but I don't really know how to word it, so I'm going to do my best. It's the 5 legs given divided by 2 times how many of the same angle.
That's pretty cool. That's pretty cool. For the 45, 45, 90. Do. Yeah. It's whatever the leg is.
They're the same, right?
They are the same on a 45, 45, 90. It's whatever the leg is times the square root of 2. Times the square root of 2. That's uber important.
There's 245 the 2 something.
Okay.
So the 2 would be this one.
Okay, this was the pattern we looked at. And if we looked at our notes from last time, right, we had, and we used different numbers, I think, but whatever, if it was 11, 11, the hypotenuse was 11 root 2. If it was 8 and 8, the hypotenuse was 8 root 2. Right, if it was 6 and 6, the hypotenuse was 6 root 2. Every time. Now, great question that some of you guys had. Matthew just asked it. Why? Why does that work? Why are you getting the square root of 2? Where is that square root of 2 even coming from? Malachi, pick your head up. So, let's suppose, for a moment, we didn't know the hypotenuse. Don't do that ever again. Okay? If I didn't know the hypotenuse, how would I find it? Yeah, it starts with a P. Pythagorean theorem, right? And here, what would that look like if my thumb was C? But be more specific, because these aren't A's. Yeah, I would have x squared plus x squared equals C squared. So, if I have x squared plus x squared, how many x squareds do I have? 2. This is the same thing as 2 x squareds equals C squared. And of course, if I'm still trying to solve for C, how do I undo that? What's the opposite of a square? Square root. So I square root both sides. Be productive if you're trying to be funny. Okay? I square root both sides. I don't know what the square root of 2 is, but what's the square root of x squared? Yeah, it's just x, and in case you don't believe me, let's look at with a number. The square root of 5 squared is 2. The square root of 5 squared is 5. Square root of 5 squared is 5. I can do that with any number. The square root of 7 squared is 7, because squares and square roots cancel each other out. They're each other's opposites, or inverse. What's that?
I was wondering if it's like required, but
No. I'm just showing it so we know what we're talking about. So, here, I have this. I have this as the square root of 2 times x squared equals C. The square root of x squared is x. I don't know the square root of 2, but that would equal my hypotenuse. This is where that 2 comes from. That 2 comes from the fact that you have 2 x squareds that you're working with. Okay. Now, properties, and the way we can use this to help us solve problems quickly. We can use these properties to quickly solve for missing sides. I'm going to give you two examples. First example. The ones we worked with last time. This is a 45, 45, 90 right triangle. And I give you that side length, and I want you to find all the missing sides. Take 30 seconds to find all the missing sides. One leg is 7. Come on. You should have something written down. Properties. Okay, so check in with your table. Please make sure you all 4 have the same answers. All 4 have the same answers. Help each other out if you need help. A little bit of a specific sentence. Who can tell me exactly why? Whitney, you feeling good or no? Why not? Is this 7? It's correct. It is 7. No, it's isosceles. Because angles, right? Angles. If the angles are the same, their opposite sides have to be the same. The angles are connected to their opposite sides. So if this 45-degree angle creates a side length of 7, this 45-degree angle must also create a side length of 7. Okay, because of the angle. Now, fantastic. Then what's the hypotenuse? Mitchell. Boom, 7 times the square root of 2. You don't have to write the little dot. I'm writing the dot so that we are absolutely positive we're multiplying. We're multiplying, we're multiplying, we're multiplying. Okay, awesome. Here you go, fancy pansies. Pansies is what I said, just to be clear. Things are getting weird.
It's been a long day for you.
My bad. Find the missing side, please. Take 10, 30 seconds.
Oh.
Yeah, he's gonna move his head past the hand. are the side lengths? Shayla. Because why? Yeah, because I know to get from the side to the hypotenuse, I multiply by the square root of 10. So if I'm trying to go backwards, I would get rid of the square root piece, right? These would just have to be 10. Because then 10 times the square root of 2 gives me square root of 2. So one thing I want to make sure we add on here. To go from the leg to the hypotenuse, what do? Mathematically, you multiply by the square root of 2. This is big. Multiply by the square root of 2. Now, this is important because guess what? To go backwards, really what we did here, was a mathematical operation, that whole ignoring the square root of 2. If to go from the leg to the hypotenuse, I multiply by the square root of 2, how do I go backwards? Say what? Opposite of multiply. Divide. Here, I would divide by the square root of 2. So there are two directions this can work. Two directions this can work. The reason you would even care about any of this, because some of you might be like, why don't I just do Pythagorean theorem? That's way easier. Because, like on this example down here, you couldn't have done the Pythagorean theorem with this example. If you're missing two sides, you can't do the Pythagorean theorem. So what this shortcut allows us to do is it allows us to solve more triangles, and in fact the most common triangles, without using Pythagorean theorem. Okay, so here's what you guys are going to do right now. You have 7 problems. 7 problems. I will give you 10 minutes to work on them. I encourage you to work on them in your groups, but you have 10 minutes to be done with the front of this. Questions, which is good. Generally something I like. What I don't like, though, is when I come and ask you a question, and I go, hey, what do you got for notes? And you go, I don't know, nothing. Well, no duh, you have questions then. Okay? I don't write these for no reason. So if you don't have notes written down from now on, I'm not helping you. You're going to waste my time and not pay attention when I'm trying to teach. Not helping you. They're meant to, like, I write them in a way that you should write them in your notebook. I write them exactly as I would recommend you write them. Right? Labeling them. So when you go, hey, how do I solve such right triangles? Oh, look, this is such right triangle. Okay? And if you aren't writing it down, even if you don't understand it, I don't care if you write it down and you have no idea what you're writing. None. But you write it down and then you go, hey, Ms.Stolte, can you help me figure this out? I'd be like, absolutely. Let's add to your notes so there's something that you understand. Okay? But not having them written down is a huge not okay piece for me. Okay? So, the other thing, the two big things we're talking about here, all we're talking about is how we can use this pattern. How we can use this shortcut. Okay? I know every time I have a 45, 45, 90 right triangle, the two legs are going to be the same every time, because those are two 45-degree angles. The two legs are going to be the same, and every time, to go from the legs to the hypotenuse, you're going to multiply by the square root of 2. Every time. Every time. I don't care what you multiply by the square root of 2. I could just leave you with that. That's the only thing you need to know. And then you just need to know that the opposite of multiplying is division. So if I'm going the opposite direction, now I'm dividing. Multiply by the square root of 2 or divide by the square root of 2. So when we're looking at these, right, on number 1, that the leg is 6 inches. That means the other one, these little marks right here, tell me the two sides are equal or congruent. So that this has to be 6 inches as well. And again, to go from the leg to the hypotenuse, like to the hypotenuse, I multiply by the square root of 2. So if I multiply by the square root of 2, that tells me my hypotenuse is 6 root 2. That's it. That's all I have to do. Ms.Stolte, is really that easy? Yes. All you have to do. Okay? The only problem is this note I wrote for you. I'll read you the note because some of you, thought I just typed it for funsies. To use any shortcuts, you must know. See how I said in caps? They're yelling at you. You must first know for sure that it's a 45, 45, 90. You can't just be guessing willy-nilly. Well, it looks 45. Okay, I hope that is not how you provide evidence for an argument. You have to know. You got to know it. Okay? Looking at this triangle, is it even 45, 45, 90? Because I don't see any 90 degree angle.
Yes.
Mariah, what? Yes, the two sides are congruent. Ian? Yeah, but that's only 145 degrees. Josephine, I heard you say. Mariah said the two sides are congruent, and you said what, Josephine? Yeah, that means if these two sides are congruent, these angles also have to be congruent. Now, I still have a problem. This is not a 45, 45, 90. Guy, what? Cool. Total degrees in a triangle is what? 180. So 45 plus 45 is already 90. That means this must then be a 90 degree angle. Okay. So it's valid, so we can do it. You have to make sure you know it's a 45, 45, 90 before you start on. Okay, so looking at number 2, because here's what a lot of you guys are going to do. You're going to be like, okay, sweet, that's 2, that's 2. I know how to get to my hypotenuse is 2 root 2. Right? Just all you're doing is multiplying by the square root of 2. The problem is that a 45, 45, 90 in there.
Yes.
Yes, because, Sam,
We know the entire shape of the square since all four sides are equal.
that is not the definition of a square.
Well, and then if it's all sides are equal and they're connected in that group duration, then those are 90 degree angles.
Cool, so here's what you guys think. Definition of a square. 4 congruent sides, 4 90 degree angles. Yes, those are 4 congruent sides. Does it say anywhere about those being 90 degree angles? No, because maybe you don't know about my little friend called a rhombus. Here's a rhombus. Brr, 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 brr.
What square doesn't look like that?
Okay? This is a rhombus. A rhombus is defined as any quadrilateral with 4 equal sides. 4 equal sides does not a square make, my friends. Okay? Yes, I agree. That looks like a square, but you don't know that it's a square.
It's a 90 degree angle.
Okay? It looks like a square, but you do not know it's a square.
I know it.
Okay?
Angles don't correspond to the sides in the square.
No, the angles, there's no opposite angle in a square. Like, the sides are opposite each other, not angles. Because that's only in triangles. Yes, Pinky? These mean that these sides are equal. Now here's the thing. Here's what could happen. This, you could say, okay, cool. For all we know, this might be a 46 degree angle, a 46 degree angle, and an 88 degree angle. Okay? You don't know. Yes, these two angles are the same. You do not know that they are 45. Lupe. What? If it wasn't equilateral? Like this would have that marker too? Yeah. Yeah, that's true. But it doesn't have that marker. No, it doesn't make it a right triangle. Again, here's the big thing I'm pointing out to you guys, because you're going to get tricked by this. I'm going to put tricks like this. Just telling you. I'm just trying to warn you. Malachi doesn't really care. He's like, I don't care. Honey badger over here. He's just going to be like, ah, take it. Okay? You do not know. You do not know. There is not enough to say for sure that this is a 45, 45, 90. Dahlia, one last comment. Good question. She said, if you do not know for sure, then can you just do normal Pythagorean theorem? No, because why? Go ahead. Because it has to be a right triangle to do Pythagorean theorem. And if it's not a right triangle, I can't do anything. If it was a right triangle, this would be 2 root 2. But we do not know that it's a right triangle. So we cannot do it. Okay? Okay, number 3. Moving on. Let's get this out of the way. Do we know it's a 45, 45, 90? Because 45, a 90, that forces this guy to be 45 degrees. Okay. Read these people.
But they're living
Okay.
M and N. That makes it not possible.
And that can be each.
Is that-
No.
Yes,
It
like-
could be.
No.
I'll even put it right here for you.
Okay. So, stop. It's okay. So then, what's the side length? Tommy, you know? Maybe pay attention then, so you can learn something today. We have the goal. What's the side length? Someone I have not heard from today. Taylor. Because why? Huh? Oh, that's kind of specific. Yeah, and specifically, Taylor, how do I go backwards from the hypotenuse to the leg? Yeah, if I divide by the square root of 2, what's the square root of 2 divided by the square root of 2? What? No. Anything divided by itself. Try this one more time. Don't say enough with the word vomit. Hold on. Give yourself a second to think. Anything. Let's take 5. 5 divided by 5. Before you answer, how many 5s go into 5? 1. Okay? 5 divided by 5. These guys make 1. And 9 times, you can say they cancel out. That's technically whatever. That's what people say. I don't like that word, but fine. They cancel out. Root 2 divided by root 2, it makes a 1. 9 times 1 is just 9. The answer here would be 9 yards. This would be 9 yards as well. Okay? Now, people then got a little bit, they're like, 4, the wrong thing. Either you went like this on 4, because you're like, I know, it's 7. And it's not 7. It's not 7. To go, Dominic, to go from the leg, from the leg to the hypotenuse, Dominic, what do I do? No. From the leg to the hypotenuse. Notice I'm using orange. Yeah, I do. Multiply by the square root of 2. So that here, this would be 7 root 2 times root 2. You guys are like, what? It looks weird. What's another way to say root 2 times root 2? Something times itself. Yes, you're right. One way, Major said root 2 times root 2 would be 7 root 4. He's correct. What's the square root of 4? Yes. So the answer would be 14. Now, hold up. That's what Major said. But also, what does it mean to multiply something by itself? What is that? Square it. I could also say that this is 7 times the square root of 2 squared. And what do we know about when you square a square root?
Cancels it out.
Yeah, that's just 7 times 2, which is again 14. All roads lead to 14. Okay? Yeah. Now, number 5. This should be obvious. What? Right, you have no idea this is a right triangle.
Oh.
No. Yes. Again. So like Mickey said, I'm going to summarize. Mickey said R and R, those are the same thing. Yes, they are. But that might mean, again, this is 47 degrees and that's 47 degrees and this is, I don't know, whatever that would be. I'll go with 86. Okay, it says, yeah, those are the same angles, but we do not know that they're 45ers. Okay, you cannot do 5. You cannot do 5. Okay. Can't do it. It's not a 45, 45, 90 as far as we know. Okay, number 6, last one. What? Why not? Because now here's, to build on what Mickey said. X and X, we know they're the same. We know these two angles must be the same. Let's ignore the top part of that triangle. Those must be the same. But we also have the 90 degrees here. So that means you have 90 degrees split up between two angles, which makes these guys 45 and 45. So, final question. How do I go backwards? Matthew. Divide by the square root of 2 so that you would get your length as 24 divided by the square root of 2. And I'm just going to leave it like that. Okay. So here's the deal. I am going to give you a single sheet of paper, for your teeth. Before you leave today, this needs to be done.